average value of a function. Suppose we have a function y equals f of x, and we can see that the values of f of x change from x equals a to x equals b. What do we mean when we say the average value of the function? Well, we know that the function y equals f of x has an area under the curve. If we find the rectangle here, where the area under this rectangle is the same as the area under the curve, that value corresponding to the y-axis here is what we define to be the average value of the function. The way to compute the average value is to take 1 divided by b minus a multiplied by the area. So now again, if you just think of this as the average value is the height of the rectangle that we're talking about here, and then we know that b minus a is the width of that rectangle. We know that the average value, the height, multiplied by the width, b minus a, is equal to the area of the rectangle. And what we want is the area of the rectangle to be equal to the area under the curve. And the only way this can be true is if the average value is equal to 1 over b minus a times the integral from a to b f of x dx. And of course, the way we get this is we just are dividing both sides here by b minus a. But that is the concept. Let's do an example. Find the average value of the function f of x equals 1 plus x squared on the interval from -1 to +2. First, let's look at what we're talking about here. So x equals -1 is right here. X equals +2 is right here. And we can see that there is an area under the curve on this particular interval. The average value of the function is going to be some number here on the y-axis such that the area under the corresponding rectangle will equal the area under this curve. Now I'm going to guess that that value is somewhere in here. Let's go ahead and compute it. So we know the average value is equal to 1 divided by b minus a times the integral from a to b of our function. So this is 1 divided by b minus a is 2 minus -1. Integral from -1 to +2, and our function is 1 plus x squared. So this is equal to 1/3 integral from -1 to 2, 1 plus x squared. Now if we go ahead and find the antiderivative of 1, we get x. The antiderivative of x squared is x cubed over 3. And this goes from -1 to 2. Plugging in 2, we get this. Plugging in 1, we get this. And keep in mind that it's 1/3 of that whole thing. And this is 1/3 times 2 plus 8/3 minus -1 is +1. And then right here we have -1/3, but then there's a negative there, so that becomes a +1/3. And this is equal to 1/3 times, let's add these up, 8/3 plus 1/3 is 9/3, which is 3, plus 2 plus 1 is 6, and 1/3 times 6 is equal to 2. And so the average value of the function is 2. Now what that means from a graphical perspective is that if we go to the number 2 on the y-axis and we draw a line straight across, the area under this rectangle, so this green area here, is actually equal to the area under the curve, the red area. So that is what is meant by average value of a function. In our next example, suppose in a certain city, the temperature in Fahrenheit t hours after 9 a.m. is modeled by the following function. T of t equals 50 plus 14 times the sine of pi t divided by 12. So capital T is the temperature, lowercase t is the time. So this says the temperature at a particular time is this. Now t is the hours after 9 a.m. So what that means is that when t equals 0, this corresponds to 9 a.m. When t equals 1, this corresponds to 10 a.m., etc. So t equals 12 would be 12 hours after 9 a.m., which would be 9 p.m., and then this goes on and on forever. We want to find the average temperature during the period from 9 a.m. to 9 p.m. So that would be the period from t equals 0 to t equals 12. Now, I have a graph of that function just for your reference. I think it's interesting to look at the graph here. If we're going from t equals 0 to t equals 12, we are looking at this part of that graph. So what is the average value? Well, we can see that at 9 a.m. it's 50 degrees, at 9 p.m. it's 50 degrees again, and 6 hours after 9 a.m., which would be 3 p.m., it is 64 degrees. So the average value is going to be the average temperature during this part of the graph here. And I'm going to guess that that average temperature is 50-something degrees, right? We don't know exactly what, but it's probably somewhere in here. So let's go ahead and find it by using the definition of the average value. So we know that the average temperature here, so we're going to call that T average, is equal to 1 divided by 9 p.m. corresponds to t equals 12, minus 9 a.m. corresponds to t equals 0, and then we will integrate from 0 to 12, and then our function is 50 plus 14 times the sine of pi t over 12 dt. Okay, now to do this integral, we basically need to do two separate integrals. We have 1/12 integral of 50 dt plus 1/12 integral of 14 sine of pi t over 12 dt. Now, the reason we have to do two separate integrals is because the second integral requires a substitution. And the substitution we're going to make here is we're going to let u equal pi divided by 12 times t, and then du is going to be pi divided by 12 times dt. Okay? Now, we've also talked about formulas for doing this kind of integral, and you could certainly use that formula here. I'll make reference to it in just a minute, but first I'll just do it using the substitution. And then here, this is a straightforward integral. So for this one, we just have 1/12, and then the antiderivative of 50 is 50 times t, and that's going to go from 0 to 12. So we can go ahead and calculate this directly. We have 1/12, and then 50 times 12 minus 50 times 0. And this, of course, is just going to be 50. So we'll save that value. Now we need to add to it the value of this other integral that you see here. So to do this integral, let's go ahead and rewrite it. So I have 1/12. I have the integral. I have a 14. Then I have sine of pi t over 12 dt. Now, why am I leaving space? Well, because we don't have the pi over 12 times dt. So I'm going to put that in here, pi over 12 multiplied by dt. And then to cancel that, I'm going to put 12 over pi over here. Okay, so if we were to multiply this and this together, those would cancel out. But the reason I'm doing this, of course, is now we can see that this is du, this is u, and this is a constant. Now, let's go ahead and make the substitution. So I have 1/12 times 14 times 12 over pi. I'm just factoring these numbers out of the integral. and then we're going to have the sine of u times du. All right, now what are my new limits of integration? Well, when t is equal to 0, referring to this limit here, we know that u is going to be pi over 12 times 0, which of course is still 0. And when t equals 12, this value up here, u is going to be pi divided by 12 times 12, which is pi. Now on the outside of our integral here, the 12s cancel out, and we have 14 over pi. And now let's go ahead and take the antiderivative of sine of u, which is negative cosine of u. And we're going to go from 0 to pi. And so this is equal to negative 14 over pi. So factoring this negative out here. And then we have cosine of pi minus cosine of 0. And this is negative 14 over pi times negative 1 minus 1. Negative 1 minus 1 is negative 2 times negative 14 is 28 divided by pi. And that is the value of the second integral. So the average value of the function is 50 plus 28 over pi. So the average temperature is 50 plus 28 over pi, and then we can plug that into a calculator to get an approximation. And this approximation is 58.9 degrees Fahrenheit. And so that gives an average temperature. Now let's just revisit this integral here, and let's talk about a different way to do that integral if you know a little bit about the substitution formulas mentioned in a previous video lesson. So the formula that we know from earlier is that if you take the antiderivative of sine of ax times dx, that this is equal to negative 1 over a times the cosine of ax plus c. This is our formula. So in this case, we have the integral 14 over 12, so I'm factoring the 14 out, and then integral from 0 to 12 sine of, and I'm going to say pi over 12 times t dt. So the pi over 12 that you see here, that I'm pulling out there, this is our value of a that you see here in this formula. And so the value of this integral is going to be 14 over 12 times, the formula says negative 1 divided by a, so that's negative 1 divided by pi over 12, and then cosine of pi over 12 times t, right? So the integral here is cosine of ax. A is pi over 12 in this case, and of course x is t for this example. But the point is we now get 14 over 12 times negative 12 over pi cosine of pi over 12 times t. And then from here the 12s cancel out and we get negative 14 over pi cosine of pi over 12 times t. And in this particular case, we really didn't use a u substitution. We used a formula. So we still have the original variable in the problem. So your limits would be the same as they were in the beginning. So it'd be from 0 to 12. And this would be negative 14 over pi times, when you plug in 12, you get the cosine of pi. And when you plug in 0, you get cosine of 0. And this, of course, is exactly what we got just a few moments ago. So that's just another way to calculate that second integral. It just requires you to know this formula. And I do think it's really important to know these basic substitution formulas mentioned in a previous lesson. Next, we have the mean value theorem for integrals. So we already know that if we have a continuous function, we can find the average value of that function by doing 1 divided by b minus a times the integral from a to b of that function. The point now is that that average value has a value of c on the x-axis corresponding to it. So if we just look at this graph again, here we have the function y equals f of x. We have the average value of the function, which can be found by using the formula. And now notice wherever that average value of the function intersects the curve, there is a value of c corresponding to it. And so the mean value theorem for integrals guarantees that there is an existence of this number c. And so one of the extra steps in these average value problems is that you may be asked to find the number c that satisfies the mean value theorem for integrals. So let's go ahead and take a look at an example. Here we want to find the average value of the function f, and then find the value of c satisfying the mean value theorem for integrals, and then we'll sketch a graph. Okay, and the function here, it's actually not called f, it's called g of x, is x plus 1 to the third power on the interval from 0 to 2. So let's go ahead and first find the average value of the function. So this will be part A. We know that the average value, which will actually be called g average for this one, is going to be 1 divided by 2 minus 0, integral from 0 to 2, x plus 1 to the third power dx. This is 1/2 integral 0 to 2, x plus 1 to the third times dx. Now again, the 2 and the 0 here are just coming from the a and the b on the interval. Now, how do we compute this integral here? I'm going to do a quick u substitution. If I let u equal x plus 1, du is the same as dx. And this integral becomes 1/2 integral u cubed du. And if x equals 0, u is going to be 1, right? And if x is equal to 2, u is going to be 3. So I'm getting those just by plugging the values of the limits into the substitution. So this becomes the integral from 1 to 3. So we have 1/2 times antiderivative is u to the fourth divided by 4 from 1 to 3. And this is going to be 1/8 times 3 to the fourth power minus 1 to the fourth power, which is 1/8 times 81 minus 1, which ends up being 10. Okay, so the average value of the function is 10. Now, the second part is, since the average value is 10, there will be a value corresponding to that average value of 10, which we call c. And what we know is that f of c must be equal to 10. So how do we find that value c? Well, remember, in this case, g of x was x plus 1 to the third power. So actually this should say g of c, not f of c. Sorry, old habits here, right? If g of c is equal to 10, well, think about what g of c is. G of c is just going to be c plus 1 to the third power. So g of c is c plus 1 to the third. That's equal to 10. And now to solve for c, we just take the cube root of both sides. This is going to give us c plus 1 equals the cube root of 10. And then subtract 1 from both sides. C will be the cube root of 10 minus 1. And that value, cube root of 10 minus 1, is approximately 1.15. So this value that you see here on the x-axis, this value of c, is approximately 1.15. And it does kind of make sense. You can tell that this value here is equal to 1. And so it does seem like the value corresponding to the average value of the function is a little bit more than 1. Now, the graph, we already have the graph, of course. Here is the graph of the function x plus 1 to the third power. Now, what we know is that the area under this rectangle here, from 0 to 2, is the same as the area under the curve from 0 to 2. Okay, so if we got all of this area under the curve here, that would be equivalent to the area under this rectangle here. Okay, and that concludes this video lesson.